Hi everyone, so welcome to my second video, and here I'm gonna talk about the system design approach for the data engineers and architects. So you have seen there's a ton of material online for the software engineers and full stack developers on the system design rounds and different rounds, but we have very less material for the data side. And system design and data modeling is a quite common subject in the interviews and in various companies as well, where you have to design the ETL pipelines, data modeling you have to do. So I would like to share my knowledge in various companies and giving multiple interviews on how you can approach a system design round. So first thing here, I'm not creating any pipeline as such, but here I'll just share my knowledge on the approach that you can use to answer any question which you can face in a system design interview and how you can excel it. So first things first, I'll first talk about few must-know concepts that you should know before moving on to a system design round. So I'll start with those fundamental concepts. So the first concept is OLAP versus OLTP. You should know what is the transactional versus analytical areas. So the traditional RDBMS that we have, MySQL, Postgres, are for the transactional requirements. But now the big data warehouses that we use are mostly for the analytical requirements, such as getting the insights, user behavior, user metrics, and giving recommendations, forecasting. All these are the analytical requirements. Second point is the fact and dimension tables. So you must be knowing this, that fact tables are having the measurable and quantitative fields mostly in their tables. So for example, if you are in an e-commerce, you are creating an e-commerce data pipeline and you have different tables. So one table can be the sales fact table, which will tell you the transaction ID, product ID, and then it will give you the measurable quantities, like how many quantities sold and what is the amount, what is the price. So this is a fact table example. Dimensions are more of contextual and descriptive information. So for a particular sales table, we can have a different product table, which will have all the product information, like like the brand, the category, and the product ID, and various things about the product. So that's how a dimension table is made. So another basic topic is star versus snowflake schema. So star schema is a centralized fact table, which is surrounded by different dimension tables. So for example, a sales table can be surrounded by a product, user, and store tables. And similarly, Snowflake schema is kind of a star schema only, where the dimension tables are normalized into different dimension tables. So for example, a particular product table has its brand and category. So we can separate out these dimensions. So star schema, when it goes into multiple direction, it creates the snowflake-like visual, which is the Snowflake schema. Also, one more point here to consider is there's a third schema type, which is called as fact constellation schema, which is kind of where we can have multiple fact tables and multiple dimension tables. And mostly in the practical use cases in the companies, we use a combination of these schemas. Another point is normalization versus denormalization. So when we reduce the data redundancy by dividing a particular table into different smaller tables, then that is normalization. And denormalization, on the other hand, is when you combine multiple tables into one single space, one single table, to have the fast read and writes, to have one point of truth. So there are trade-offs in normalization and denormalization, and you should know where to normalize the table and where to denormalize. Again, very important topic is SQL versus NoSQL databases. Also, guys, you should not just know about the bookish definitions here. You should know the practical examples of where these SQL and NoSQL databases are getting used, and what other definitions or concepts that we learned, where it should be used as a practical knowledge. So SQL is mostly used in the relational databases where we have a defined schema and where we have relations between multiple entities. And in NoSQL, the schema can change, and also we can store unstructured or semi-structured data. So let's say if there's an activity log through a social media website, so that can go to the NoSQL database. So similarly, you should know the practical use cases of these databases. Now, a very important point is CAP theorem. So this is a theorem which is mostly used in the big data world, and which says that consistency, availability, and partition tolerance. So when you are creating a data pipeline or data design, you can have either of these two, either consistency and partition tolerance, or availability and partition tolerance, or the other one. So it depends on the data design, and it says is that you have to trade off one entity here to achieve the other two. So for example, consistency and partition tolerance, if we take, so if there's an e-commerce platform where if there is a downtime, so we stop having the new writes into the database. Why? So what it will do is it will reduce the availability for some time, but the data is consistent all over the nodes. Similarly, availability and partition tolerance is when you upload a tweet on any social media app, let's say, and there are different nodes. So if you post a tweet from India, so you might, the US person might get to see it a little bit late. So what it is doing is the consistency will be delayed for some time, but your post can be available at that time only. And if the partition fails, in that case also you'll be able to post or read the tweets. So this is availability and partition. And for consistency and availability, I think the traditional databases that we had, MySQL and all, we had consistency and availability, but if the node fails, then everything fails. So these are the trade-offs. Another point that you should know is the data warehouse versus data lake and databases. Data lake is generally to store the raw format data in structured or semi-structured format. Databases is for more of the relational databases where we have traditional databases like MySQL, PostgreSQL, and data warehouse is for the big data volume of data. Now, another thing is that you should be knowing about the different data sources that we have. So we can get the data through the API calls, through the RDBMS systems, through the NoSQL database. It can be the flat files like CSV or JSON, and it can be activity logs, it can be real-time data through the sensors or IoT devices. So you must be aware a little bit about all the data sources that you can get and how to process that data through different methods. So next point is batch versus streaming data. You should know about this, like when to use the batch consumption of data and when to use the streaming data. Streaming data is mostly used for the real-time analytics, and just read about some practical use cases where the real-time is using. So mostly the companies in today's world are asking about the real-time analysis because everyone wants to do their analysis in a fast manner. Another point is distributed computing and distributed storage. So what's happening in the big data world right now that we distribute the data across various nodes. So what it does is that we have replica, or we can say the backup of the data or the task. So if a particular node fails, then we have the backup option to get the task again up and running. So we achieve the fault tolerance here, and also we have the quality data pipelines. One more point I would like you to understand is about the SCD type tables. These are the slowly changing dimension, and there are around 4 types of dimension tables. So it tells you about where you can store the history or not. So there's incremental data and historical data, and there are different permutation and combination of how you can store the historical data with the incremental data. Also, finally, I would like to talk about some general tech stack which is getting used in lots of places. So for example, we use a messaging broker called as Kafka. Orchestration pipeline, we generally use Airflow. For the fast retrieval of data and transformations, we use Spark or Apache Flink. Apache Flink is mostly used for more real-time data processing. And data warehouses, we have various cloud functionalities like AWS, GCP, and Azure. So you should know a bit of like wherever you are applying it. If it is asking about AWS, just go through the tech stack of AWS. What is the data warehouse? What is the storage like AWS S3? And finally, we have some dashboards for reporting purposes, where Tableau is a very hot topic in the data science community where we do the reporting. Also, you can see some monitoring and alerting tools like PagerDuty and Datadog, which is very beneficial for giving you alerts if your pipeline fails, and also to monitor the state of your pipelines. So I tried to do a quick touch base on the topics and must know fundamental topics that you should know before going on to the system design round. And as I said that you should deep dive into these concepts and you should know it by heart before going to the rounds, because these are very basic things, and the interviewer will grill you on these topics only. Okay, so now coming on to the actual approach for the system design rounds. So I've divided this approach into 6 parts, and I'll go through one by one. So the first first domain is about the clarifying questions. So let's say that interviewer asks you about a question of creating a data design for the e-commerce website or e-commerce platform, or design a data pipeline for a social media app or the tweet app. So now the first point is the clarifying questions. So first, you should spend minimum 3 to 5 minutes on the clarifying questions to understand the question better. So this will help you also, and also the interviewer will watch that how you're going to approach the question. And one more thing to remember is that in these kind of rounds, it's not a interview round. You can take it as a peer-to-peer discussion on designing a system. So first thing is clarify the questions. So a few general questions are, let's say that what is the volume of data which is coming in, and what is the scale of users that we are targeting, and what are our different data sources, like is it SQL database, NoSQL, or is it flat files like CSV or JSON, and do we need the history of this data, and what is the latency, what is the time run of the frequency of running this, is it a daily job or a weekly job. So questions like these will help you also to understand the question better and prepare the approach better. So please spend 3 to 5 minutes on the clarifying questions first. The second point is functional and non-functional requirements. So in this step, take 5 minutes to clear out the functional and non-functional requirements, such as here you can talk about the scalability, latency, reliability of data, availability, fault tolerance. Also, you can ask the interviewer, is it a batch time data or is it a streaming data? What analytical requirements are we facing? So accordingly, you have to create the design. And do you need the history of data to be stored? And it will be insert, merge operations, or whatever. And also the data governance part you can ask, and do we need the monitoring and alerting. So these are the functional and non-functional requirements that you can put in front of interviewer to make your case more solid with the clarifying question, that you know that you have to build your design on these lines. Now, the third part is the product metrics. Now, most of the companies are looking at the product metrics, and it's beneficial for data analysts and scientists as well, because at last, after the data is in the data warehouse, when it goes to the reporting tools like Tableau, we gain some insights out of it. And what are those product metrics? For example, we want to analyze the monthly active users or daily active users, or we want to know how many users signed up in the last month or last year, and what is the downtime or uptime of a particular process. And so these are kind of the metrics, these are the product metrics which we analyze at last, and we send it to the business stakeholders to make the decisions on top of it. So it contains the user behavior, user engagement, the processing timeline of some systems, and there can be lots of product metrics. It depends on what you are trying to achieve and what you are trying to analyze. So make sure that you know a little bit about it, because just knowing the engineering concepts and you don't know what you are gonna do after it and what analysis you are gonna take out of it, then it wouldn't make much sense. So you should know end-to-end process. Now coming on to the main part, which is the high level design. Now we will start with the high level design. So here generally interviewer asks you to draw some chart or flow chart in the Excel draw. So where you can draw the system design, actual system design. And here we can start from our various data sources, and we can ask him like what are the data sources. Then after that we can use something like a messaging broker like Kafka, which will combine all the data from different data sources, get it into Kafka, and then send it across for the processing. After Kafka, if you want to load the data in some data lake, let's say AWS S3 or GCP, then you can do that, so that your raw data stays in your AWS S3 buckets for some time, and you can do a transformation on top of it. And now you can design it something like, if you want a different ingestion pipeline, which is taking the data and ingesting data, and processing pipeline is different, that is up to you. And then maybe you can use Spark for getting the data through AWS S3 and doing the transformations on top of it in Spark. And finally, you can load the data into some data warehouse. So if you are using AWS, then AWS Redshift is their data warehouse. You can use BigQuery, GCP BigQuery, and Snowflake also. And instead of Spark, you can use dbt. So these are different tech stack that is there. And as per the JD of the company, you should know like what tech stack you are going to use. And finally, I think on top of it, there should be an orchestration pipeline which will run the production pipelines, and that is majorly through Airflow. And the reporting dashboards can be made on Tableau. Also, one important point is that what monitoring and alerting tools you want to put to your system design. So PagerDuty and Datadog are very famous tools which you can use to do the monitoring and alerting of your systems. Now comes the next point, which is the low level design. It's not actually low level design, but I say it as low level design because we are going deeper into the analysis part and what our design will look like in terms of tables and different structure of data. So for example, in our e-commerce example, we can take a similar fact table like sales, which is a centralized fact table which will have information of the sales amount, the quantity sold, and the price. And across that, we can have different dimension tables like the product, the user, date table, store table, which will have the dimensions and informations about different products. So you can go deep dive into it, and there you can be asked questions like what will be the insert and merge operations. Here you can be asked about the SCD type tables, and here you should know about the indexing and partitioning of the data, and what will be the primary keys and foreign keys. So these concepts will be used in this part of your system design when you are going into some low level and you are creating the data types and data tables for your system design to be more robust and solid. Or maybe the interviewer can just focus on this part only. So you should know about how to design a data model or different tables as per your system design considerations. And finally, the last point is to summarize your approach. You should be very well knowing what you built, and you should be confident on what your system design looks like. So you should summarize your approach from the very starting to the very end. So whatever the latency scalability factor that you considered in the starting, that should match with your system design, and finally what you have solved. Summarize this approach in a very well prepared manner, and it will have a good impact on the interviewer. Finally, there can be some follow-up questions on the system design round, like the trade-off questions: why you use AWS not GCP, why not Snowflake, why Spark not dbt, etc. There can be some follow-up questions on SQL based on your data model that you provided, or there can be some Python questions. So be ready for it, that you can get some follow-up questions on your system design rounds. And as I said, it's not a, don't think of it as an interviewer round, think of it as more of a peer-to-peer design discussion round. In that case, you are just discussing with your interviewer what can be the solutions. You have to think out loud. There's no perfect solution in the system design round. It's all about thinking out loud and what you can think of. So just think of it as a discussion round with your peer to solve a problem. So thank you everyone for watching this video. And if you really like the content and if it is helping you for your preparations, then do like, share, and subscribe. Also, I'll try to create more system design pipelines for different use cases in my next round of videos. So stay tuned, and thank you very much.